Find the Maclaurin series of sine x then. So f of x is sine x. Now we need to differentiate, which is fairly straightforward to do, isn't it? F dashed, sine goes to cosine, and then cosine goes to minus sine, and then the minus sine goes to cos, there's a minus in front of it, and 4. Cos goes to minus sine, so we're back to sine. And then, let's do one more, f of 5 of x here, sine goes to cosine. So there's a cycle, isn't there, that you can see it repeats, starts again here. So, let's work out the f of zeros, so to speak. So f of naught, sine naught is naught, f of dashed of naught, cos naught is 1, double dashed at naught, sine naught is naught, f of 3 at naught, cos naught is 1, so we've got a minus 1 here, f of 4, naught, sine naught is naught, and f of 5, cos naught is 1. So we can see that the ones are alternating in sign on these terms, dashed, 3 and 5. So we've got f of x then. So we can just write down these terms with non-zero f's, can't we? So we've got the f of naught is naught, we've got f dash, we've got one lot of x. Then this double dashed is 0, this term, so we move on to this one, and we'll have minus x cubed over 3, factorial, and then the fourth one 0, then the fifth one will be plus 1, and it'll be the x to the 5 over 5 factorial, won't it? This was 3 factorial, of course, and then minus dot dot dot. So we've got odd powers, so we can write an odd power of x as 2r plus 1 for any number in whole number r over the 2r plus 1s. Now if you had 5, for example, 5 in here, r would be 2, and that's a positive. So if I put minus 1 to the r, you can see when that would this total was 5, r would be 2, and you'd get a plus. And when r is 1, if you see 1 in here, you'll get 2 1s plus 1 is 3, and you'll get 3 here. And when r is 1, you'll get a negative, which is what you want. And these signs will alternate from subsequent terms. So we had a negative in this position, we had a positive in the next place along, and then it will alternate as we would wish, doesn't it? So there's the sequence then, and that's the general term. This is the function of sine x, of course, so let's put it in. And this is valid for all values of x, radian values, of course. So this series holds for all x, any real number x.